move on to the polar covalent bonding, where just as we saw, there is an unequal sharing of electrons. Just like this unequal cutting of an apple, unequal sharing, this also is due to unequal sharing of electrons. Let's see how it goes about with an example like, so let us just first write it is due to unequal sharing of electrons. And whenever there is an unequal sharing of electrons, charges will be formed. Okay, there is a possibility for the charges to be formed. Now let us take an example like water. Okay, when we take water as an example, it is H2O, which means there is one atom of oxygen and two atoms of hydrogen, and it is a covalent bond. So let us take oxygen, atomic number is 8 and hydrogen's atomic number is 1. So the electronic configuration would be 2, 6 for this and 1 for hydrogen. How do we write this? Let us take oxygen, we write it as in the center. Okay, and how many electrons does it have? 6 electrons in the outermost shell. Therefore, 1, 2 and 2 pairs. Now this pair is generally, these 2 pairs don't react with any other element. Therefore, this is called as lone pair of electrons. This also is called a lone pair. Okay. Now coming to the hydrogen, there is one hydrogen atom here with one electron, another hydrogen atom here with another electron. Now these three are the ones which are going to combine oxygen and hydrogen together. Now once it combines, you get something like this. These two electrons, so 6 are there. Hydrogen shares its one pair and this hydrogen shares its another electron. So one pair of electron shared, one pair of electron shared, and these are intact. Now what happens here is, see, oxygen is a non-metal, hydrogen is also a non-metal, but oxygen is electronegative, highly electronegative, which means it has an affinity for electrons. So what it does is slowly pulls the electrons to itself, towards itself. So oxygen thereby becomes slightly negative, whereas hydrogen would become positive. Sharing is happening, but there is unequal sharing. It is pulling the electrons towards itself. Okay, this is called as polar covalent and it is represented like this only. One pair shared, one bond formed, and this is what is water molecule. This is how it is formed. Okay, this is water. Similarly, we also have the next example is ammonia. Ammonia comes as NH3. It is between nitrogen and hydrogen. Now when we talk about nitrogen, the atomic number is 7 and hydrogen's atomic number is 1. The electronic configuration would be 2, 5 and this would be having 1. Now how do we go about this nitrogen? Let's put in the center. Okay. Now there are 5 electrons in the valence shell. So 2 electrons alone and 3 electrons here need to be shared with 3 hydrogen atoms. The hydrogen atoms have one each. Okay, now this is how they are combining. So this nitrogen, this also and this also are combining. So as a result of this, you would get, okay, nitrogen and the hydrogen atoms like this. Again here also we have this pair of electron. This is called as the lone pair. Alright, now it is only forming single bonds everywhere. So this is represented as hydrogen and this we write it as NH3. Here it is water and this is NH3. So this is how unequal sharing happens. Why we do say this is because here again nitrogen is more electronegative just like oxygen. So it pulls the electrons towards itself, thereby there is a negative charge that is formed in the nitrogen, whereas these electrons, all these atoms would get a positive charge. Charges are formed as such, they don't have, covalent bonds will not have charges, they are not ionic compounds, but charges are formed and that results in polar covalent bonding. Okay, so charged particles, because of unequal sharing or unsymmetrical sharing of electrons, is called polar covalent bonding. The third type of covalent bonding is coordinate covalent bonding. See, supposing I come to your house and I have no other place to stay and I have to be accommodated in your house, and you say that, okay ma'am, I will share my room with you. Okay, so the room belongs to you, but you are sharing your room with me and the whole room is yours. Like I don't have anything there, nothing belongs to me, but it belongs to you, but the sharing comes from you alone. Now I can't after 10 days say no, this is my room. No, because the sharing is from your side and you are sharing it with me, and that is how this coordinate covalent bonding comes. So sharing is from one side, but it also has a sharing there, but the sharing comes from only one side, then it is coordinate covalent bonding. Let's see this with three examples in fact. One is the formation of ammonium ion. This actually comes from ammonia. Okay, ammonia is a polar covalent compound. So when we start with ammonia, we have nitrogen and we have one lone pair and 3 electrons here and 3 hydrogen atoms like this. Now there is a lone pair here. Lone pair is an unshared pair of electrons. Any unshared pair is called as a lone pair. Okay. Now what happens here? If one more hydrogen ion comes here. Okay. Remember, hydrogen has only atomic number 1, which means it has 1 electron and 1 proton. When that electron goes off, there is only 1 proton. All it has is only 1 proton here. Now this approaches nitrogen because it needs 2 electrons very badly. Okay, so nitrogen says, don't worry, I will share my pair of electrons with you. Okay, so that is how it is formed. So this goes, and nitrogen with 3 here. These hydrogen atoms are already there, but this one is shared with this hydrogen. So bonding is formed. Okay, this one, because it shares this electrons, but there is one, remember, one proton is there. So that one positive charge is in excess, which we should not forget to add on. Now if we represent this in the form of dashes, it is slightly different. Now this between hydrogen and nitrogen, between these three, there will be only a single bond that is formed here. But only here, because the sharing comes from one element only, and which is that element? It is nitrogen. So from nitrogen to hydrogen, we represent it by an arrow mark. Okay, then the other hydrogen atoms are written this way. But don't ever forget to don't miss that positive charge, because it is one positive charge in excess. So whenever we do this, we should take care that either you write 2 dots and that is being shared, or you represent it by a arrow mark which denotes that the shared pair comes from nitrogen to hydrogen. Don't put both together, that will be a mistake. Okay, so this is the formation of ammonium ion. Okay, the next one is formation of hydronium ion. Hydronium is H3O plus. NH4 plus. Okay, how do we form this? Again we go back to water molecule. So the electron dot structure of water was like this. It had 2 lone pairs this way, and so a total of 6. How do we get 6? Because oxygen has an atomic number 8, which means the electronic configuration is 2, 6. So we have a total of 6 here. And there are 2 hydrogen atoms, one on this side and one on this side. So that means there are, here you have 1 lone pair, here you have 2 lone pairs. Oxygen atom has 2 lone pairs. We have to label them like this. Now what happens? There is another hydrogen ion that comes here. Remember, hydrogen ion is not having any electron and is badly in need of 2 electrons. Okay, so we write, when we go ahead, and hydrogen here, oxygen in the center with the 2 lone pairs. Hydrogen can come a little closer. Okay, and that positive charge is written here, because the total of charges, there is one excess positive charge, that charge comes over here. Okay, this is the formation of hydronium ion, and when we represent it this way with only the bonds this way, and okay, and not missing the positive charge here, that gives you hydronium ion. So this is how a hydronium ion is formed. The last one, we move on to formation of hydroxyl ion, that is OH minus. When we take water molecule, it can split into H plus and OH minus. This is possible. So when we take a water molecule, again we draw this structure, okay, and hydrogen here and another hydrogen here. This is the structure of water molecule. Now from this water molecule, one hydrogen has been removed, okay. So when that hydrogen is removed, oxygen is left with more electrons rather, okay. So the total of 8 are there, but the electron count is 1 electron more, therefore it gets a negative charge. This is how hydroxyl ion is formed, and of course in addition to that we have H plus. These are the ways in which this coordinate covalent bonding is formed. Okay, the last part of the bonding that we have seen covalent, we have seen electrovalent. Let us see the differences based on these topics. The first one being the state. Okay, all electrovalent compounds are crystalline and hard solids. Why are they hard solids? Why are they crystalline? Mainly because they are bonded by strong electrostatic forces of attraction. The same thing here. When we come to this, it is all solids, liquids or gases. High boiling and melting points. Covalent compounds have low boiling and melting points. Now for both these things together, the reason is strong electrostatic forces of attraction. Because of this, they need high temperature to break them down. Whereas these are bonded by weak van der Waals forces. So it's very easy for them to be broken down, whereas these have. So both these points have the same reason. These are bonded by strong electrostatic forces of attraction. Here you have weak van der Waals forces. Okay, conduction. Ionic compounds are good conductors of heat, whereas their covalent compounds are bad conductors. When you come to electricity, usually ionic compounds in the solid state, they will not be electrolyzed, they will not conduct electricity, whereas these are non-conductors, whether they are in the solid state or fused state or aqueous state. In aqueous or fused state, ionic compounds are very good conductors, because for electrolyzing we need ions, and it is formed by aqueous or fused state. Then these can be ionized in solution. The moment you drop it in water, they can just break into ions. Here we cannot ionize them. They are made of molecules. Again we go back to electrolysis. But there are some polar covalent compounds like ammonia and water which can be ionized. Even HCl also can be ionized. Let us take HCl. Yeah, ammonia and HCl. These can be ionized in solution in the presence of water. So this much we do about chemical bonding.